Precision Tree 6.0 includes 3 new tools that you should find very helpful when building complex trees. 1. Bayesian revision. This automatically flips a tree and performs Bayes' rule calculations when the given probabilities are backwards from those needed in the tree. Number 2. Append symmetric tree. This provides a simple interface for building a symmetric tree very quickly. The resulting tree can then be modified as necessary. Number 3. Insert node. This very handy new feature allows you to insert a new node and corresponding branches anywhere in an existing tree, not just at the end. Version 6.0 also includes a new feature, Copy Subtree Image, which allows you to copy a subtree and paste it into a Word or PowerPoint document. In fact, it was used here to paste the image of the completed tree into an Excel worksheet, as will be shown briefly. All of these new features will be illustrated here with the following drug testing example. The problem is to decide whether to test an athlete for drugs. If the test is performed, the result will either be positive or negative, but the test is not perfect. For either test result, there is then a decision on whether to ban the athlete from sports. The consequences depend on whether the athlete actually uses drugs or not. A similar sequence occurs if no test is performed. In that case, the decision on whether to ban the athlete can be made immediately. Here is an image of the completed tree. It shows what we want to achieve. Focus now on the structure. We first decide whether to test. If we test, we get test results. Then we make a decision on whether to ban the athlete from sports. Finally, to find out what the consequences are, we check, is this person a drug user? If there is no test, we make the decision on whether to ban immediately, and again find out whether the athlete is a drug user. There are 3 given probabilities. The prior probability, 0.05, that the person is a drug user. The probability, 0.07, of a false negative test result. And the probability, 0.03, of a false positive test result. Unfortunately, these are not the probabilities required in the tree. We need the unconditional probabilities of positive and negative test results, and we need the posterior probabilities of drug usage given the test result. That is, we need Bayes' rule. Here is the sequence that will be used to build the tree. First, build a symmetric probability tree using the given probabilities. 2. Flip the tree with Bayesian revision. 3. Insert decision nodes where required. The tree won't actually be finished in this tutorial. You can do this in the standard precision tree way using the same tools available in pre-6.0 versions. Step 1. Create a new tree in the usual way. Then right-click the end node and select Append Symmetric Subtree to get the following dialog box. Fill it in as you see here and click OK. You are literally spelling out what the tree should look like. This tree appears immediately, and you can label it with the given probabilities. This is the probability of a false negative. It's negative when it should be positive because the person is a drug user. And this is the probability of a false positive. It should be no because this person is not a drug user. Note that these should be entered as numbers, not cell reference formulas. Step 2, Bayesian revision. To flip the tree and implement Bayes' rule, right-click the leftmost chance node, select Bayesian revision, and accept the defaults in the resulting dialog box. The tree automatically changes as you see. For example, there is a 7.5% chance of observing a positive test result, and the probability that the athlete is a drug user given a positive test result is 62%. By the way, if you flip the tree again, you would return to where you started. Step 3. Insert nodes where required. Now you can use the new Insert Node feature to complete the structure of the tree. You can refer to the completed tree image for reference if you need to. First, right-click the leftmost chance node and select Insert Node. The tree automatically changes as you see. You can relabel the new node and its branches in the usual way. Also, if you needed more decision branches from this node, you could right-click the decision node and select Add Branch. But this feature is not new to version 6.0. Next, right-click the top right chance node, select Insert Node, and relabel in the obvious way. I won't actually do the relabeling, but you could. Then repeat for the bottom right chance node. Again, you could relabel in the obvious way. You would now complete the tree by using standard precision tree tools that are not new to version 6.0. Here's what you would do. Copy this subtree and paste it here. You would copy this subtree and paste it here. You would copy this subtree and paste it down here, changing the probabilities to the original prior probabilities. And finally, you would put the consequences, payoffs, and costs on the various branches. The important point is that you now have the tools to develop a fairly complex tree like this one in a matter of minutes. The procedure is not only quick, but there is less chance of making errors. Just remember the following points about the new tools. First, Bayesian revision works only on trees with all chance nodes, that is, probability trees. Second, the symmetric in append symmetric subtree is somewhat limiting, given that many trees are not symmetric. But this tool can still provide a starting point. You can often modify the symmetric tree fairly easily to get what you need. Third, the Insert Node option always provides a node with two generically labeled branches. However, you can add branches as needed, and you can add your own labels fairly quickly.